Class 10 student, class 10 student, arithmetic integers, advanced maths, your exercise 3.3. The main theory of it is that here it is given that is if B divides A, that means A is equal to BC. BC, that is where C belongs to integer, for any integer. So now the first question is, if your A divides B, if A divides B, then show that you have to show that minus A divides B, A divides minus B, and minus A divides minus B. So this is A divides B, this is given to you. A divides B, that is B is equal to AC. Now we can write this also like this: B is equal to minus A minus C. So B is equal to minus A minus C. I can write any other integer, say minus C I can denote by some M. M belongs to Z. Therefore, we can write that minus A divides B. Again, A divides B, which implies that B is equal to AC. Now I require minus, so when I multiply both sides by minus A C, so this I can write as minus B A minus C. So this minus B A M, where M belongs to integer. So or you can do one thing, M equal to minus C, it belongs to some integer. Here also M equal to minus C, and it belongs to some integer, so I can write that A divides minus B. And for the third case, that is A divides B, so I can write that B is equal to your AC, and minus both sides. If I multiply minus, so I can write this as minus A divides minus B. This is how you can prove it. It is not so tough, so you can prove this easily. Uh, so you can prove this easily. Mm, I think so. It is, there is no difficulty in proving it. So you can do it like this. Now, question number two. Question number two. That question number two. Again, uh, we have to show that first, if A divides B, that means implies that, which implies that A divides BC. So so you can do this. A divides B means B is equal to AC. So B is equal to AC. Uh, yeah, A divides B, that means B is equal to AC. And now you can uh, do one thing here, that is A divides B. mm, that means A divides BC. For this, you can do one thing, that is you can do one thing. You have here, this is A divides B, that implies that A divides BC. In A divides BC, that means you have to bring like that BC is equal to AK, where K is some constant. So it's okay, there's no difficulty. You multiply both sides by C, so BC will be equal to AC square. So BC will be AC square. So this C square, it is an integer. Uh, so um, so I can write that A divides BC, where C square belongs to integer, because C is an integer. So as per theory, C square belongs to integer. I can write like this. And for second, that is A divides B and A divides C, which implies that A square divides BC. So here again A divides B, that means I can write this as B is equal to AC, and A divides C, here I can write C is equal to say AK, where K belongs to integer. So now from 1 and 2, from 1 and 2 I can write this B is equal to AC, and B is equal to A, value of C is AK. So B is equal to A square K. So here K belongs to integer. So I can write that A square divides B. So I can write that A square divides BC. So let me do one thing here. Again I multiply both sides by C. Again I multiply both sides by C. So this will be BC is equal to A square KC, and your KC, this belongs to a integer. So I can write that A square divides BC. I can write like this. You can adjust it yourself, because C is an integer. As per theory, C is an integer. It is given here itself that in the theory A is equal to B, and B divides C, and if there exists no no any integer satisfying, then no one minute, here it is saying in the definition it is given any integer is said to be divisible by another integer b if there exists an integer c. So here c since c is an integer, that means c belongs to z, so c square is also an integer. And similarly again here also instead of c I placed here a, and I multiplied both sides by c, so even k and c both are integers. So a square divides bc. I can write a square divides bc. So this is question number 2. Now I am going to question number 3. Question number 3. Here it is here uh, true or false. If A divides B plus C, then your A divides B or A divides C. For this, we can take an example. We can take an example that is 2 divides 3 plus 5, or you can say that first of all 2 divides 8. So I can write like this as 2 divides 3 plus 5, but here you see that 2 does not divide 3 and 2 or 2 does not divide 5, so it is false. Now this is first, and for second, here again if A divides n and B divides n, which implies that AB divides n. So here you can take an example that is 2 divides 8 and 4 divides 8. So AB, that is 8 divides 16. So it is 2. Now I am going to question number 4. Question number 4. A, that is first, if 2 to the power of n plus minus 1 to the power of n plus 1 is divisible by 3, we have to prove this. So to prove this, here this is the mathematical induction method has been used here to prove this mathematical induction. That is, first of all I am going to represent as in example 1, that is the mathematical induction process they have used here. So Fn, this will be 2 to the power of n plus minus 1 n plus 1 is divisible by 3. So F1, this is equal to, for n is equal to 1, first of all 2 to the power of 1 minus 1 to the power of 1 plus 1, 2. So this comes our 2 plus 1, 3, and this is divisible by 3. So here your F1 is 2. Now I am going to, for n is equal to k, Fk, that is equal to 3 to the power of k minus 1 to the power of k plus 1, and it is divisible by 3. Let us take it as 3 lambda because it is divisible by 2, and let Fk be true. So I am going to Fk plus 1. So this is 3 to the power of k plus 1 plus minus 1 to the power of k plus 2, and we have to prove that this is divisible by 3. We have to prove it. So what they have done here, that is Fk plus 1 minus Fk, here this will be 3 to the power of k plus 1 plus minus 1 to the power of k plus 2 minus 3 to the power of k plus minus this will be minus minus 1 to the power of k plus 1. So now here you see this is 3 to the power of k into 3, and this will be k plus 1 into minus 1, and minus 3 to the power of k minus minus 1 to the power of k plus 1. So here again you see that this and this, so this will be uh, so here this becomes 3, so this will become 2 to the power of 3 to the power of k, and this will become uh, minus 2 to the power, this will become, this and this will be minus 2 to the power minus 1 to the power of k plus 1. So here I have a problem that it has comes to be minus, because this is minus 1. So minus minus this becomes minus 2. So here I have to make some adjustment, that is k plus 1 plus 1, and actually this is if this was a plus, then it would have been how to solve it. So here let me think about it. I have to make some adjustment here, that is 3 to the power of k plus 1. So 3 to the power of k into 3, and plus minus 1 to the power of k plus 1 minus 1 minus 3 to the power of k, and minus minus 1 to the power of k plus 1. So here 3 to the power of k, instead of 3 I can write 2 plus 1, and minus plus this will be minus 2, this and this will be minus 2 to the power k minus 2 to the power minus 2, because this and this will be minus 2, minus 1 to the power of k plus 1, and minus 3 to the power of k. So here 2 into 3 to the power of k, same thing happens here. There is something problem here. Let me adjust it. How to make the adjustment? Let me see the question. It is it's okay. Oh, I made a mistake here. So it is creating a problem. Here it is 2 to the power of n, and I have written here 3 to the power of k. So I was finding what is the problem going on. 2 to the power of k, this is 2 to the power of k, and this is 2 to the power of k, 2 to the power of k. Now I think so I can solve it. So this will be 2 to the power of k into 2 plus minus 1 uh, to the power of uh, k plus 2 and k plus 2 minus 2 to the power of k minus 1 to the power of k plus 1. So this and this will become this and this 2 minus 1, because 2 to the power of k common, 2 minus 1. And here and similarly here this will be k plus 1. So this is minus. So here again, if I take minus plus, um, the problem coming out here is that um, I can write this as minus 1 to the power of k plus 1 into minus 1 and minus 1 to the power of k plus 1. So uh, let me do one thing here. This will be far more better if I can do like this. That is uh, minus 1 to the power of k plus 2, and here instead of minus this I can write plus minus 1 to the power of k plus 2. So this will be equal to 2 to the power of k, and this will be equal to this 1 plus 1, 2 into minus 1 to the power of k plus 2. Again there is a problem coming here, that is minus 1 k plus 1 and then k plus 1. So this is minus 2, but here it is uh, instead of 2 I can 2 to the power of k 3 minus 1, and this will be uh, minus 1 to the power of k plus 1 minus 2 to the power of k minus 1 to the power of k plus 1. So this will be 3 into 2 to the power of k minus 2 to the power of k, and here uh, uh, and again here this will be this and this will be minus plus minus 2, minus 1 minus 2 to the power of minus 1, this minus 1, this 2 to the power of minus 1 k plus 1, and then minus 2 to the power of k. So here this will be 3 into 2 to the power of k, this and this will be minus 2 into 2 to the power of k, and this will be minus 2 minus 1 to the power of k plus 1. So here you see 3 2k and minus 2 common, so 2 to the power of k plus minus 1 to the power of k plus 1, and this will be equal to 3 into 2 to the power of k minus 2 into 3 lambda, because this value is how much? 3 lambda. So now from here I can move that, that is 3 common. So here from here I can write 3 common, that is 2 to the power of k minus 3 lambda. So this I can write it as 3m, this is equal to 3m, and here that is f k plus 1 minus f k, this will be equal to this. So here again your this here again, that is f k plus 1, this will be equal to plus f k, and this is equal to 3m plus 3 lambda. Here this is 3 lambda, so 3 common, m plus lambda, and this is equal to, I can write it as this. So uh, so therefore I can say that f k plus 1 is divisible by is divisible by is divisible by your 3, is divisible by 3, which is as per in your book it is written. Thus we can say that thus if f n is divisible by 4, is divisible by 3 for n is equal to k, then it is also divisible by, then it is also divisible by 3 for n is equal to k plus 1. This is a mathematical induction method. So here you see that it took a time while solving this. That is nothing else. Here you can see 2 to the power k plus 1 minus this. So 2 to the power k is 2 to the power k into 2. So instead of 2 I wrote here 3 minus 1, and now I divided into two part. So here again you see this is uh, minus 1 to the and minus 1 to the power of k plus 1, and minus 1 to the power of k plus 1. If you take minus 1 to the power of k plus 1 common, so here minus 1, so this will be equal to minus 2 minus 1 k plus 1. So this will become this much, this will be, so here I have written, therefore this and this I have minus 2 minus 1 k plus 1, and now if this 2 again 2 to the power of k minus 2 to the power of minus x minus 2x, so this is 2, and now I have taken 2 minus 2 common here, and this is divisible by 3 because here you can see fk, this is 3 lambda, and now uh, this is 2, so here now I have taken this 3 common, and this fk, it is 3 lambda, it is given. So this is how we can prove it. Question number 4.1. Now I am going to question number 4.2. Here it took a little bit of time while solving this problem, because first of all I made a mistake here, and there's this setting, it took a time. Now I am going to question number 2. Now I am going to question number 2, that is question number 2. Here you see question number 2, 4 a 2. Again here it is, I have to take this as fn is equal to because it is it takes equal to um, fn equal to uh, 3 to the power of 3n plus 1 plus 2 to the power of n plus 1, n plus 1 is divisible by, it is divisible by 5. So again I have to test for n is equal to 1. For n equal to 1 I have to test it, that is f1, that is 3 to the power of 3 plus 1 plus divisible by 5, uh, 3 to the power of plus 2 to the power of 2, so this becomes 3 to the power of 4 plus 2 to the power of 2, that is 9 9 is 81 plus 4, that is equal to 85, and this is divisible by, this is divisible by 5. Now for n is equal to k, that is fk, that it will be equal to 3 to the power of 3k plus 1 plus 2 to the power of k plus 1, and this is equal to 5 lambda. So now for n, let this be fk be true. Fk, let fk be true. So now to take fk plus 1, 3 to the power of 3, k plus 1 plus 1 plus 2 to the power of k plus 1, and then plus 1. We have to prove that this is divisible by 5. So f k plus 1 minus f k, this will be 3 to the power of 3 k plus 3 plus 1, and this will be 2 to the power of k plus 1 uh, plus 1 minus 3 to the power of 3k plus 1 minus 2 to the power of k plus 1. So here I am going to write it like this: 3 to the power of 3k plus 1 plus 3, and here I am going to add 2 to the power of k plus 1, and this is plus 1 minus 3 to the power of 3k plus 1 minus 2 to the power of k plus 1. So this will be 3 to the power of 3k plus 1 into 3 cube, and this will be 2 to the power of k plus 1 into 2 minus 3 to the power of 3k plus 1 minus 2 to the power of k plus 1. I can write it like this. So here again, this is 27, 3 to, so 27 I can write it as 25 plus 2. So 3 to the power of 3k plus 1, 25 plus 2, and this will be 2 to the power of this and this, when this and this, that means 2 minus 1, 2 minus 1 into 2 to the power of k plus 1, and this will be minus 3 to the power of 3k plus 1. So here it will be 25 into 3 to the power of 3k plus 1 plus 2 into 3 to the power of 3k plus 1, and this will be 1 2 to the power of k plus 1 minus 3 to the power of 3k plus 1. So now this and this will be 1. So 25 into 3 to the power of 3k plus 1, and this will be 1. So plus 3 to the power of 3k plus 1 plus 2 to the power of k plus 1. Now we know that this part, you see this part, it is 5 lambda. So 25 into 3 to the power of 3k plus 1 plus 5 lambda. This is 5 lambda. So here you can say 5 common, and this will be equal to 5 into 3 to the power of 3k plus 1 plus lambda, and this I can write it as 5m. So now I think so it is correct. 3, so 3k plus 3, and this I have written 3, 27, 27 means 25 plus 2, and here this and this, 2 to the power of k plus 1 common, 2 minus 1, and this remains here. So again this is again 2, 3 to the power 2, 3 to the power 3k plus 1, 2 minus 1, this will be 1, and this is this, so 5 lambda, so this is 5m. Now your f k plus 1 minus f k, this will be equal to 5m, and your f k plus 1 will be is equal to 5m plus f k. So this will be equal to 5m plus 5 lambda, so 5 common, this will be m plus lambda, so you can write as 5p. So here again, that is, in short I am writing it, uh, that is you have to write this last statement. It is important, you have to write it. That is mm, thus mm, thus if fn is divisible by, if this is divisible by divisible by 5 for n is equal to k, then it is also divisible by, then it is also divisible by 5 for n is equal to k plus 1, for n is equal to k plus 1. So in this way you can prove it. Now I am doing this question number 4b for you. 4b for you, that is similarly this is the same pattern, you have to do it in the same pattern. So 4b 4b 4b, this is for 4b, that is fn is equal to 3 to the power of 2n minus 1 plus 2 to the power of n plus 1 is equal to this is divisible by divisible by is divisible by 7. So here again for n is equal to 1, we have to check it because this is the procedure is mathematical induction process. So 3 to the power of 2 minus 1 plus 2 to the power of 1 plus 1, that is 2. So this will be equal to 3 plus 4, this is 7, it is divisible by 7, so f1 is true. Now for fk, this is equal to 3 to the power of 2k minus 1 plus 2 to the power of k plus 1. Let this be equal to 7 lambda. Now for n is equal to k plus 1, that is fk plus 1. This will be 3 to the power of 2 k plus 1 minus 1 plus 2 to the power of k plus 1 plus 1. So here again you have to prove that this is divisible by 7. So fk plus 1 minus fk, this will be equal to 3 to the power of 2 k plus 1 minus 1 plus 2 to the power of k plus 1 plus 1 minus 3 to the power of 2k minus 1 plus 2 to the power of k plus 1. So this will be equal to 3 to the power 2k plus 2 minus 1 plus 2 to the power of k plus 1 plus 1 minus 3 to the power of 2k minus 1 2 to the power of k plus 1. So here this will be 3 to the power of 2k minus 1 plus 2, and this is again same k plus 1 into 2 and minus 3 to the power of 2k minus 1 plus, oh this will be minus not plus, this will be minus minus 2 to the power of k plus 1. So this will be 3 to the power of 2k minus 1 into 3 square, and this and this part and this part, this will be 1 because 2 minus 1, this will 1 2 to the power of k plus 1 and minus 3 to the power of 2k minus 1. So this will be 3 to the power of 2k minus 1 into 9 plus 2 to the power of k plus 1 minus 3 to the power of 2k minus 1. So 9 means 7 plus 2. So I can, instead of 9, I can write as 7 plus 2, that is 3 to the power of 2k minus 1 plus 2 to the power of k plus 1 minus 3 to the power of 2k minus 1. So this I can write as 7 into 3 to the power of 2k minus 1 plus 2 into 3 to the power of 2k minus 1. How can this, this is plus, this is plus, plus 2 to the power of k plus 1 and minus 3 to the power of 2k minus 1. So here Now again, this is equal to 7 into 3 to the power of 2k minus 1. This and this will be 2 minus 1, 1. So this will be 3 to the power of 2k minus 1 plus 2 to the power of k plus 1. So this will be 7 to the power of 3 2k minus 1, and this is, you see, this is this one, this part. So this will be plus 7 lambda. So this will be 7 lambda. Now I'm now I am going to this here, f k plus 1 minus f k. This will be equal to 7 common 3 to the power of 2k minus 1 plus lambda. So this I can write it as 7m. Now fk plus 1 is equal to 7m plus fk, and this is equal to 7m plus fk. This is 7 lambda, so this is 7 common m plus lambda, so this is 7p. So here again with the same statement, that is, you have to write if fn is divisible by, if this is divisible by 7, if this division 7 for n is equal to k, then it is also, then it is also divisible by, then it is also divisible by uh, then it is also divisible by 7 for n is equal to k plus 1. This is your proof. Now I am going to 4bc, 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 that is 4c. This is again fn is equal to 3 to the power of 4n plus 2 plus 5 to the power of 2n plus 1 is divisible by, is divisible by 14. So here again for n is equal to 1, for n is equal to 1, 3 and 1, that is 4 plus 2, 4, 6 plus 5, 1, 5, no, 1, 3. So this will be 3 to the power of 6, that means 3 to the power of 6. 3 to the power of 6, let me calculate it. That will be 3 to the power of 6, that means how much? Uh, mm, uh, 3 to the power of 6, that means 3 square, uh, 3, 9 cube, that means 9 9 is 81, 81 into 9, this will come out to be 729, 729 plus, oh sorry, this will come out to be 729 plus 729 plus 125, so plus 125, this will be how much? 8 54, and this is divisible by 14, and this is divisible by 14, that is 1 minute. Mm, uh, 854, 854 divides how much? 14, 1 4 61. It is divisible by 7, and this is divisible by 14. Now for n is equal to k, fk, this will be fk, this will be 3 to the power of 4k plus 2 plus 5 to the power of 2k plus 1, and this is equal to 14 lambda. Let your fk be true. Now fk plus 1, this will 3 to the power of 4 k plus 1 plus 2 plus 5 to the power of 2k plus 1 plus 1. So we have to prove that this is divisible by 14. So f k plus 1 minus f k, this will be 3 to the power of 4 k plus 1 plus 2 plus 5 to the power of 2 k plus 1 plus 1 minus 3 to the power of 4 k plus 2 minus 5 to the power of 2 k plus 1. So here I can write this as 3 to 4k plus 4, that means 4k plus 2 plus 4, and this as 5 to the power of 2 k plus 1 uh, 2k plus 1 plus 2. That means let me do like this, that is 5 to the power of 2k plus 1 and then plus 2 minus 3 to the power of 4k plus 2 minus 5 to the 2k plus 1. So this will be equal to 3 to the power of 4k plus 2 into 3 to the power of 4, and this will be 5 to the power of 2k plus 1 into 5 square minus 3 to the power of 4k plus 2 4k plus 2 minus 5 to the power of 2k plus 1. So this will be 3 square and 9. 9 and 81. This will be 81 into 3 to the power of 4k plus 2, and this will be 25 5 to the power of 2k plus 1 minus 3 to the power of 4k plus 2 minus 5 to the power of 2k plus 1. Now there is a question here arises that 3 this oh, question arises, there is a question that comes before here. I've got two things, that is 5 square and here 5 to the power of 2k plus 1, 14 lambda, so I have to make 14 lambda. 4k plus 4, this is 4k plus 2 3, means that is 9 and 81, and this is 5 2k plus 2, so 5 square 25. Now here I have to do something so that it becomes divisible by 14, that is 25 14 28 minus 2 and 81 14 4 14 4s are 4 4, that's 14 5s are 14 5s are 14, that is have to make something 14 81 you divided by 1 4 5, that means 14 14 into 5, this will be 70 70 70 divided by 14, 17 45 14 6 into 6 84, so 84 and 84 84, that is this is minus, so this will be 80 and this will be 24, 80 and 24. 80 is not divisible by 40, 80 divided by 1 4, and 24 is also not divisible by, So I have to make some adjustment here. How to make the adjustment? That is 81. This will be, you can write it as 4 minus 1, and this 5 square 14 division 14. So this part it is 14 lambda. I have got this part, it is 14 lambda, but for this part it is 14 14 and 14. If you minus 14 here, so this will be 14 if you minus 14 here, so 28, and this will be 84 minus 4, 28 minus 2, 28 minus 2. We can make some adjustment. 24, 28 and 14, 4 4s are 16, no, 14 2s are 2 4s are 2 4s are 8. Means if I 28 minus this and this, let me try 84 minus 3. 84 minus 3, that is 81, 3 to the power of 4 k plus 2, and this will be 28 minus 2 into 5 5 6 7 minus 3, sorry, 28 minus 3, because this 25 plus 3 is 28, 5 to the power of 2k plus 1 minus 3 to the power of 4k plus 2 minus 5 to the power of 2k plus 1. So this will be 84 3 4k plus 2 minus 3 into 3 4k plus 2, and this will be 28 into 5 2k plus 1, and this will minus 3 into 5 2k plus 1 minus 3 to the power of 4k plus 2 minus 5 to the power of 2k plus 1. So here in this part, if you take this and this, here 14 is common, so 14 6 are 84, so this will be 6 into 3 to the power of 4k plus 2 and plus 14 2s are 28, 2 into 5 to the power of 2k plus 1, and for this part and this part, if you take minus 3 common, this will be minus 3 plus minus 3. If we take minus 3 common, if we take minus 3 common, so this will be 3 to the power of 4k plus 2, and this and this, this and this one and this one, see this one and this one, so my plus 5 to the power of 2k plus 1, and now this minus common, 3 to the power of 4k plus 2 plus 5 to the power of 2k plus 1, so 2k plus 1. So now here I can do 14, and I can let this be m minus 3. This is 14 lambda into 14 lambda, and this is minus 14 lambda. So this will be 14m minus 4 into 14 lambda. So here my problem is solved. F k plus 1 minus f k, here this 14 common, so this will be m minus 4 lambda, and this will be 14p. I can take 14p, so this is divisible by 14. Now I can write the statement here, that is thus thus I can write this statement here. Thus I can write the statement as if fn is divisible by divisible by divisible by 4, divisible by 14, divisible by 14 for n is equal to k, then it is also divisible by, by 14 for n is equal to k plus 1. So a part up to 14, up to 4, question number 4, I have proved it, I have done it for you. Now this I have done it for you. Here this part, this is common, and for this and this it is here -3 common, and for this 2 part. So from this I have done up to question number 4. Now here you can see that is your here you can see one thing, that is one thing that is 5 you can do it yourself. This is question number 5, you can do it yourself, because this is you have done in your class 10 general maths, you have done in general maths, so you can do this yourself. You have done in general maths question number 5, you can do it yourself, this question number 5, because you have done this in general math. So in the second part I am going to, this is my first part, I am going to over it. In the second part from this question number 6, I am going to deal with question number 6, because question number 5 it is already you have done in your general. So this is the first chapter. So now from in the second part I am going to do from this 6. So my first part is over here. What part is over here?